Look at this question. This question is, what is this question? A block of mass m sliding on a smooth horizontal surface as shown in figure with a velocity v. So this is moving with velocity v, meets a long spring fixed at one end and having spring constant k as shown in figure. Find the maximum compression of this. Will the velocity of the block be the same as when it comes back to the original position shown? Okay, so first we have to find the maximum compression. So this is the initial configuration. Final configuration will be the spring is compressed, okay, and object is here. So in this position, so if this position we call it A and this we call it B. Okay, so what is the difference in energy at these two positions? So difference in energy, if you write, see, work done external is 0 here, as we saw in the last cases. Work done external is 0. Why? Because work done external is equal to the work done normal, that is 0. So normal is acting upward and displacement is horizontal, that's why. Okay, and gravitation is not going to do any work because the movement is horizontal. So we can write delta K, the change of kinetic energy, plus delta U, change of spring potential energy, equal to 0. So delta K between point A and B, between A and B. Okay, so at A, the kinetic energy is half mv square, and at P kinetic energy is 0. So final kinetic energy is 0 and initial is half mv square. Okay, so final kinetic energy is 0. At maximum compression, it will stop for a moment. So velocity will be 0. This is the maximum compression. Maximum compression. At the position of maximum compression, the object stops momentarily. That's why we have written velocity 0. So final velocity is 0 and initial is v. So this we can write as v dash. So v dash is 0 and initial velocity is given v. And spring potential. And so finally, suppose it is compressed by x. The compression is supposed by x. So we can write final is half kx square and initial was 0 because initially spring was relaxed, is equal to 0. If you solve it, the maximum compression is going to be x equal to v under root m by k. Okay, so v under root m by k. So this is the maximum compression which we are going to have. Okay, okay. Now come to next part of the question. Will the velocity of the block be same when it comes back to the original position? So when it comes back to the original position, suppose it compresses and then again coming back after compressing it maximum, suppose again it relaxes, the spring relaxes, okay, and the object got separated. So object started moving in backward direction. Okay, so since spring is now again at 0 energy, so if we write, suppose this position is called C. So if we write delta K plus delta US equal to 0 for A and C position. Okay, so change of kinetic energy and change of potential energy. So change of potential energy will be 0 because spring was initially relaxed, finally also relaxed. Change of kinetic energy half m v. Suppose we write capital V. Suppose it is going with capital V, and initial was half mv square equal to 0. So the capital V square equal to small v square. Okay, so this gives the idea that velocity magnitude is same because squares are same. So speed is same. The final speed is same as initial speed. Final speed is same as initial speed. Okay, but the velocity will be opposite. Why opposite? Because initially the object is moving forward and finally after relaxing, the velocity is negative. Okay, so speed is not, velocity is not same. Velocity is changed. Okay, so velocity is changed. Velocity